Well, hello there, students, amazing people, whoever you are watching this video all across the globe. You're welcome to the fourth video in this series where we're dealing with the topic of mole concepts. And up next, we're going to be talking about moles and gases. I'm sure you're super excited for what I've got coming up for you in this series. So let's go ahead and check out what we have. So first things first, as far as gases are concerned in chemistry, something powerful was discovered. And what's that powerful thing that was discovered? At certain conditions of temperature and pressure, 1 mole of any gas occupies the same volume. That volume is 22.4 dm³. So when certain conditions of temperature and pressure are attained, the volume occupied by 1 mole of any gas, whatever gas it may be, is 22.4 dm³ or 22.4 liters, whichever one you choose to use. So whether it's oxygen, hydrogen, carbon dioxide, whatever gas it may be, as far as it's a gas and it is under certain conditions of temperature and pressure, I'll be telling you what that is. 1 mole of a gas occupies 22.4 liters or 22.4 dm³. So what's that condition? It is the standard temperature and pressure, STP, okay? So STP is actually an acronym in chemistry that stands for standard temperature and pressure. Now, when those conditions are occupied or attained, 1 mole of a gas occupies 22.4 dm³. That's decimeter cube or 22.4 liters. Now, how do we apply this to the calculations in the mole concept? Well, that's what we're here to do. So let's proceed. Normally, in our previous videos, when we're solving questions, we're usually looking at conversions from mass to moles, from moles to number of particles, number of atoms, and all of that. But when we're dealing with gases, we deal with volume because that's the amount of space that they occupy. So when we deal with volume, we're dealing with the conversions from volume to number of moles or from number of moles to the amount of volume occupied. And we're going to be showing you how that can be carried out. There is a formula to use, and that formula says the number of moles of a gas is given by the volume that it occupies divided by 22.4. Okay, so the number of moles is equal to the volume that it occupies divided by 22.4. Now, this volume that it occupies must be measured in dm³ or in liters. Because when we're dealing with the volume occupied by gases, we use the units of dm³ or liters. So let's solve an example and see if we can understand one or two things. The example starts off by saying find the number of moles in 44.8 dm³ of oxygen at STP. So we know the formula says the number of moles of a gas is given by the volume occupied by that gas in dm³ divided by 22.4. So the volume that it occupies is 44.8 dm³, as you can see over here. So we just quickly divide it by 22.4. So the number of moles will be given by 44.8 divided by 22.4. If your calculator punches correctly, that should give you 2 moles. It is as simple as ABC. It doesn't get easier than that. By the way, if you're enjoying today's lesson, consider subscribing, liking, and sharing this video. And do well to engage with it in the comments. I look forward to seeing, reading, and answering your comments. Now, I want to see if you understand something. You may start with volume, and then they may be asking you to calculate the mass of the gas. How do you do that? There's nothing to fear. You just follow the stages. You convert it into the number of moles, and then you convert the number of moles into the mass of the gas that you are looking for. So let's see if we can solve a few examples and do justice to that. So example number 2 says, what is the mass of 22.4 dm³ of CO2 at STP. So first thing we want to do is to calculate the number of moles of gas that occupies this volume. And remember, the number of moles of a gas is equal to the volume occupied by that gas in dm³ divided by 22.4. So this becomes 22.4 divided by 22.4. This is equal to 1 mole. Now that we have the number of moles, we can now go ahead to convert this into mass using the formula that says number of moles is equal to the mass divided by the molar mass. Now we know the number of moles to be 1. We do not know what the mass is, and we can also calculate the molar mass of CO2. Let's do that very quickly. We know that C is 12. That's the atomic mass of carbon, and the atomic mass of oxygen is 16. So if we are calculating for CO2, it becomes 12. How many atoms of carbon are present in CO2? It is just 1. So we have 12 multiplied by 1 plus oxygen, which is 16, multiplied by 2 because we have 2 atoms of oxygen over here. So it becomes 12 plus 32, and that becomes 44. So therefore, we know the number of moles to be 1. The mass is not given because that's what we're looking for. And then the molar mass is 44. So we can quickly plug in our values into this formula to find the amount in mass. So let's do that very quickly. Number of moles is equal to 1. The mass is unknown. And the molar mass is equal to 44. So let's plug that in. Number of moles, which is 1, is equal to the mass, which is unknown, divided by the molar mass, which is 44. So we can just quickly cross multiply from here, and then we have the mass is equal to 1 times 44. This is equal to 44 grams. It doesn't get any easier than that. Did you see how the steps were taken? First of all, we converted from volume over here into number of moles, and then we converted from number of moles into mass. It doesn't get any easier than that. I'm sure you're enjoying every bit of today's lesson. So here are some exercise questions that I want you to carry out. And not to worry, I'm going to be posting videos showing the solutions to these questions. So just sit back, relax, and enjoy every bit of what I've got for you. So here is the first set of questions. These are basic ones that you can handle. And here is the second set of questions. These are an intermediate section, and then we have the third set of questions, which are examination standards. I want you to take out your time, solve them, give them a go, and let me know what you arrived at in the comments section. I hope you enjoyed today's lesson. Up next, we're going to be looking at formulas that can be derived from the mole relationships. I look forward to seeing you in my next video. Once again, if you enjoyed, please consider liking, sharing, and subscribing, and I'll see you in the next video. Thank you.